Welcome to a new garden rail related video, and today I'm revisiting actually a 10-year-old project because as you can see in this sample footage, sorry for the vertically shot video, but I have these coaches in which I installed lights, and these lights were my first version of the flicker-free lights. Basically just include a bit of buffer so the lights in the coaches keep lit even if the coach runs over dirty track. And it was good, but it was just not good enough, and I thought it's time to revisit this project and do a better version, like a version 2.0, which is well, hopefully it's actually going to better perform. And it's winter, the weather is miserable outside, so I only managed to take this very few seconds of footage when I was just testing two coaches. The one which is closer to you is the one which is using the new type of lights or light circuit, and the old one is the older one. So you can see that the further away is the older one, and you can see that the further away is flickering more than the new one. So obviously it looks like this new circuit is working, and so I'm building this new circuit for each of my coaches, and hopefully in a couple of months time, when the spring comes and the weather is going to be slightly bit better, I could actually test it how it performs on like in a full loop around the track. But hopefully it's going to be fine, so I'm really looking forward to the result of this project. But today I just want to talk you through this whole thing, how it started. And I want to say thanks for PCBWay for making the PCBs for this project. You will hear about them a little bit later in this video. This video is sponsored by PCBWay. PCBWay is a manufacturer of all type of PCBs, offered PCB prototyping services, but you can also order fully assembled PCBs as well. If you need flexible PCBs, you are covered too. Besides PCBs, they also offer CNC machine services, 3D printing as well, with a huge selection of materials and printing technology. I am an absolute beginner when it comes to electronics and PCB design, and all my projects are about designing special boards where I use development boards and maybe some passive components. But I have to tell you that these boards are already light years from the breadboard projects in terms of looks and reliable operation. And these PCBs really turn my prototype projects to live projects that I will use for the years to come. If you like my projects, I always link a link to my PCB that you can order directly from PCBWay. Or if you want to buy a different board or service from them, please use my referral code, which you will also find in the video description. And actually I think I'm going to switch to a full desk view so we can see the whole thing. So a couple of things I need to rearrange on my desk. Well, maybe actually let's look at the subject. So the coaches are in question are these Märklin coaches. They are quite standard ones that have been produced for a long time, and they come in a lot of different versions. And the only reason you see this gap because I removed the top. But this is a 5-axle coach from Märklin, which was quite popular in the German railways. By default, they come with electrical pickups that you can see on the two outer wheels, and these provide electricity pickup from the inner side of the wheels, so the coach can be powered from the rails. And of course it's only two wheels, so there are definitely issues with how reliably it can pick up electricity from the coach. And what you can see, what I showed in the previous video, is I installed these LED strips. Well, basically two small sections of the LED strip. I picked up an LED strip which had the least amount of LEDs per meter because I didn't want a floodlight in these coaches. And so you can see two small sections with 3 LEDs each. And actually I managed to use the toilet compartment to hide all the wires. Well, these wires I just had to push a little bit down. So actually you can see that the feed comes through just above the axles. or the two outer axle, and then it goes here, and that's where my electronics was housed. And then it goes to these two, LED strips. Fairly simple. These are 12-volt LED strips, and yeah. So there are two issues with this circuit, which I wanted to address in this new version of the light. Well, first of all, as you can see from the video, it still flickers. The second issue is that it was still too strong for these LED strips. So I wanted something which has where I can control the brightness down or control the voltage, and that was the two reasons I decided to redesign the circuit. And actually, this is the first design that I created. It's a very simple one, and this is the first version of the circuit that I created, and it's a very simple circuit because all it does, it has a bridge rectifier because I'm using DCC, where the polarity changes. This is how they encode data into the track. But even if you use DC, then once you change the direction, the polarity changes. So it's a good idea to use a bridge rectifier. Did I say DC? DC? No, this is a bridge rectifier. So the track voltage comes through here, and then it goes into this LM7212 linear voltage regulator. I think it's, or 7812, yeah. And this is a linear voltage regulator, and you can see that it has a heatsink because linear voltage regulators are easy to use, but they are not really efficient. And there is a capacitor to store extra charge. So when the power is cut, then this capacitor is going to provide voltage for the LEDs to be lit. And when I was addressing the issue of this circuit, actually, I learned a lot about like basic electronics, which I probably should have known. But then, as things are pointed out to you, you start to realize the mistakes you made and, how simple the solution to this problem is. Well, so basically, I had adopted this changed this in two different ways. Well, first of all, I used a much bigger capacitor. So you can see this is 22 microfarad and this is 22,000 microfarad. So that's going to store a lot more electricity, and that should keep the lights on for much longer. The second is that I replaced the linear voltage regulator with a very small DC to DC converter, which you can see here. That small unit. Actually, you can see a bunch of them in this board. This is how I purchased them from AliExpress. So there is 6 of these, and they pretty much cost next to nothing. And they have a small pot, so you can regulate the outside, or you can set the outside voltage, and that already fulfills one of my criteria because this was a 12-volt linear regulator, so this outputs a fixed 12 volt. So I can use this pot to turn the voltage down to 9 volts, which gives a much discrete light from these LED strips. So these 6 LEDs are a little bit too much for this coach, but if I have used less, then the light would not have been so uniform. So the only other option I had is to reduce the voltage, so it makes it less bright. It's not like like a very strong coach light. After all, these are not very modern coaches, so this originally would have been like filament light bulbs, so like a decent brightness, but not awfully not too light. So that's one of the change. Other than that, I still used a bridge rectifier here, and as I said, the capacitor is bigger. But the other big change what I have done is this capacitor is in front of the DC-DC converter. And the reason this is important because as it was pointed out to be, so in this design, the capacitor was storing the 12-volt voltage, which was powering the LEDs as well. But this one is actually storing the 18-volt voltage, which comes from the track. So once the track power is disconnected, there is more charge left in this capacitor because, obviously because it has a higher capacitance, but it is storing 22,000 microfarads at around like 18 volts, as opposed to the 2,200 microfarads and 16 volts. I mean, obviously there is going to be some voltage drop and losses on this DC to DC converter, but I think it's still going to be better. So these are the two main changes on the circuit. And I also added this resistor because when you connect this, then obviously this capacitor charges up very quickly, and this resistor is added in series, so it reduces the charge current a little bit, and hopefully it's going to just be a little bit more gentle on my power supply, especially multiple coaches disconnect and reconnect at the same time. So without this, I measured that it was putting like 1.5 amps when it was charging up, and I think this one there is still a spike, but it's probably like lowered to like 800 milliamps or something around that. I mean, I don't have a proper oscilloscope or supply, so I was just looking at a peak on a digital meter, so obviously it has a limitation, it has some limitations. And of course I designed this whole thing around the space that is available in the toilet, and this huge capacitor still fits in. And that's pretty much it. And I was so happy with the performance of this test unit, then I decided that I'm going to create my own PCB. So I created this set of PCBs and I manufactured them. Well, I got them from PCBWay. So I have 15 of these circuits. I have components for about, I think, 10 of them or 9 of them. Well, this is going to be the 10th. And I mean, it's just so nice. It looks so professional. Well, of course, everything looks so professional once you manufacture them from PCBWay. And this is how the finished article looks like. And if you look at the circuit from up close, you can see that there is a bridge rectifier. I placed the resistor over to the other side, the two prongs for the capacitor, and that's the DC-DC converter. And if I flip it around, then you can see that I have these 2-pin female pin headers. Probably they are not the best because they are not, you can just plug them either way. For the track, it doesn't really matter which polarity you plug it in, and for the lights, I marked it what is positive and negative here. And if you are using LED strips, if you plug them in the other way around, they would just not light up. So, not huge harm is going to be done. But you can use any other connectors because there is space here. So if you use like a small JST or something, you want to make sure about the polarity, you can use that. And I decided to put the connections on the underside because the roof sort of curves like this. So there is more, place for the wires to go that way than the other way around. And if I want to show you the components, I'm using these 10 ohm 1 watt resistors. So I just bought them from a local electronics supplier. I have these capacitors. So as I said, 22,000 microfarad, 25 volts, and well, these are Jamicon branded, so I think the only thing, is important, at least for the PCB, that the pin spacing is 10 mil for this particular model. So if you want to make sure that it fits inside the PCB, as you can see, positive and negative is marked here, so it's easy to align. Yeah, simple as that. And I have a set of these bridge rectifiers. So not that I wanted this specific package, but when I was asking for a bridge rectifier, I got this small package, and actually it just makes it easier to make this whole circuit a little bit more compact than the usual, than the older version, which has the more sort of traditional rounded design. That's easier to, you can just push them flush into the PCB and they take up less space. So it's very easy to do, and I've also included some footage on actual soldering it. The only trick is you have to get the resistor in first, because obviously you see that the soldering goes on the other side, so you won't be able to solder it once the capacitor goes in. And also the capacitor makes it difficult to solder the DC-DC in as well. So it's pretty much the capacitor goes in last, mostly because of you know, how it's sandwiched in the PCB design. And I found, I thought that I can get this DC-DC in by just placing it on top of the pads and flowing this with solder, because this has holes on it. So I thought I just align it there. Actually, it's the other way around. And I put solder in, and that's going to flow through the pads, but it's not doing that. So what I ended up doing is I put a small wire through these holes, and actually I soldered the wires in here, and then I pushed the DC-DC through, and I soldered on top of it, and it was really painful. So I think what I'm going to do when I do the next one is I'm just going to push this in, and I'm going to have some, you know, I always keep all the cut legs of resistors and stuff, so I would just push those legs in, and I will bend them out on both sides, and I'm just going to solder them in from both ends, and that's how I'm going to make sure that they are electrically connected. So that's going to be a quicker job to do, but I struggled through the soldering the wire in first, and it was really painful. You were going to see the footage a little bit later, but yeah, these are cool. And of course, the link to these PCBs is going to be in the video description. So if you want to order yours, then you know, you can just head to PCBWay and just place an order, and that's it. Simple as that. And I left you some soldering footage so you can see how I assemble these panels. I have 3 of them at the moment, so I'm going to install them, and I'm going to do the rest of it, you know, maybe in a couple of months' time. I still have plenty of time until the spring weather comes, and I can finish all these coaches. Okay, so I cleaned up my mess on this table, and now it is time to set up these units. And basically what it means that this DC-DC converter comes from the factory with some settings. I don't know the exact setting, but it is not set to the voltage that I need. So I'm going to create a very simple test jig, and for this I have, oops, just one sec, I pinched the cable. So here on the one side I have this Rydon power supply, and I'm not sure how much you can see that. So it is set to 18 volts 1 amp, which is close enough to the DCC track voltage. And I have created this lead which terminates in 2 pins, and I'm just going to connect this. So that's going to be the feed voltage or the track voltage, which goes into the unit. And actually I'm going to use this for testing because I've already configured this. And so it goes in like so. And I need another piece of cable. So I made a second piece of cable, and that goes into the lamp, and we are going to measure the voltage. And I am pretty sure I had 2 of these cables which terminates in the crocodile clips, but I can't find the second one. So I'm going to use this, and we will set this one to voltage. And how I can do this so it doesn't reflect the lights, I think I'm going to prop it up with this. Good enough? Yeah, good enough. Okay, so this is what I wanted to check, because so the other main purpose of this unit is obviously to lower the track voltage, and I'm using the 12 volt strips, and at 9 volts they give like a really sort of like subtle orangey, well, not orangey, but like warm glow. So the whole thing is that I wanted to reduce the voltage even from 12 volts down to 9 volts, which obviously helps with the power consumption and how much time the capacitor can basically breach. But again, I think the coach lights are more prototypical if they are not at full 12 volts. So again, it's very easy to do. You just need a power supply which can go, well, it can go above 9 volts, because once you set it, it doesn't really matter what the input voltage is, it will always set the fixed output voltage. So again, like if you have like a 15, 14 volt power supply, even a 12 volt power supply, you can do it. And oops, too much. So you can always tweak this. If you need 9.5 volts, then you can do that later on. So that's 9.1. Actually, let me just... Yeah, so if I don't get the screwdriver exactly on that, I'm not really twisting anything. Okay, 9.6, 9.9, 9.1 is good enough. So I turn off the power supply, and you can see I turn up the power supply off, and you can see that we still have output voltage. Of course, there is no load, so it takes much longer for the capacitor to run flat. But when I have the LEDs on, they draw about like 100 milliamps. So this capacitor lasts about, I don't know, like roughly like half a minute or something like that, 20 seconds. And now you can see that the voltage starts dropping. Okay, so that's the end of my project. If you are interested in doing something like this, your own, you will find the link to this PCB in the video description. Thanks again for PCBWay for making these videos. But that will be all for today. Thanks for watching, and hopefully see you in the next video.